Hello and welcome back to video number 3 in this series of videos on how to use a hand calculator in celestial navigation, specifically working with degrees, minutes, and seconds. I'm Chris Kreitline, a celestial navigation instructor with Globus Horizon, and our website is www.globizon.com. Now, in the last 2 videos, we talked about the fundamentals of using hand calculators and the fact that all calculators seem to be different. There's of course some similarities, strong similarities, but each manufacturer makes the calculator how he wants, and they have not standardized the processes. So you have to be careful which calculator you get, that you don't get one that's impossible for you to use. Now we talked about that, and we stepped through the buttons to push and the functions to use and all of that. Well, this time I'm going to actually go through a series of problems that you might encounter when doing celestial navigation. We're not going to do a sun sight or anything like that, but we're just going to step through some calculations that are typical of a celestial navigation problem. And in doing this, I'm going to use this calculator, which in the previous video I said was probably one of the more difficult ones to use. More buttons to push. Now, one good thing about this calculator that you may have noticed when I went over it was that it displays the information with the symbols for a degree, minute, and second. Whereas the other two I demonstrated, only you had the little circle for a degree. Whereas this one actually, in the display up here, will display degrees, minutes, and seconds with those symbols. What do I mean by that? Well, the other calculators that I showed you might very well show something 45 degrees, 15 minutes, and 10 seconds. You notice they all put the little degree symbol up here. This calculator will actually give you a degree, 15 minutes, and 10 seconds. So that's one thing good about it. But of course, you've got to push extra buttons in order to have that privilege of that display. Okay? So anyway, I'm going to use this one, and we're going to work some problems. Okay, now one celestial phenomenon that is critical to celestial navigation is the fact that the sun crosses 15 degrees of longitude every hour as it circles the earth. I once had a guy write me a note and tell me I was stupid because I should know that the earth goes around the sun and not the sun around the earth, as I said in my video. Well, of course, I know that the earth goes around the sun. But for the purposes of celestial navigation, we assume the earth is standing still and everything else is going around the earth. So please don't write me any nasty comments that I don't understand the heavens. Okay? All right. Now here we have the earth, and this is the North Pole. So we're looking down on the earth way above the North Pole. And here is the 0 degree longitude line, and here is the sun. Now the sun is over the 0 degree longitude line, which of course comes all the way down from the North Pole. It is a meridian of longitude. It's there at 12 o'clock. Now the sun in 1 hour will be over here. So this is where the sun will be in 1 hour. And here it will be at 15 degrees west longitude. In another hour, it'll be over here at 30 degrees longitude. Now you may be up here at, let's say, 145 degrees west longitude. And you're wanting to know how many degrees there are between you and where the sun is. And you can look up the sun's position in the Nautical Almanac. You'll learn that in the Celestial Navigation class. But what I'm wanting to show you here is how you subtract degrees to determine how many degrees the sun will have to travel to get to you. And you could divide that by 15, and it'll tell you how long it'll take the sun to get to you. Okay? So, keep this image in your mind. Here's the sun at noon over the 0 degree longitude line, and that in fact is called the prime meridian. You'll learn that in class. And every hour it moves 15 degrees. So, let's work a couple of problems. Okay? Let's say that we are at 145 degrees, 15 minutes and 10 seconds west longitude. All right? And the sun is right now, when you look in the Nautical Almanac for where is the sun right now, it tells you that it is at 30 degrees, 21 minutes, and 33 seconds. Okay, west longitude. That's where the sun is at this very second. Here's where we are, here's where the sun is. Now, how many degrees separate us from where the sun is? Okay, let's punch this in our little calculator. We're going to put in, let's hit the clear button, and we're going to punch in 145, hit the degree button, 15, hit the degree button again, and now we've got to move it over to the minute symbol, and then 10 seconds. We enter in 10, and we hit that button again, and we have to move the cursor over to the second symbol. So now the calculator knows, okay, that we have entered 145 degrees, 15 minutes, and 10 seconds. All right, so now we can hit enter. And it displays that 145 degrees, 15 minutes, and 10 seconds with the nice little symbols up there. Now we're going to subtract from that, okay, the sun's position. Why? Well, let's look here. If we're at 145 and the sun's down here at 30, we want to know this distance in degrees, minutes, and seconds. So we're just going to eliminate this part right here by subtracting it from the total. So we're going to subtract 30 degrees, 21 minutes. Once again, we got to move it over to the minute mark, and then 33 seconds. And we've got to move it over to the second symbol up here. Then we hit enter. Okay, now we've got the problem in there. We should be able to hit enter one more time and get the answer. All right, it tells us, this is the answer it gave us, 114.8936 blah blah blah. Well, as you know from the previous video, the computer or the calculator gave it to us in decimal places. Well, we don't want it in decimal places. We want it in degrees, minutes, and seconds. This is saying it's 114 degrees, 0.8936, blah, 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 of another degree. Well, we want it in degrees, minutes, and seconds. So we will come up here on this calculator. Now yours may be entirely different, but on this calculator we hit the degree function again, and this time we will hit the left arrow, and it takes us to DMS, degrees, minutes, seconds. We hit enter once to tell it we're going to change this to degrees, minutes. We hit it again, and it gives us the answer. The answer is 114 degrees, 53 minutes, and 37 seconds. That's how far the sun is from us around the earth. 114 degrees, 53 minutes, 37 seconds. Now I'm going to show you one other little thing we can do. I told you that the sun travels 15 degrees in an hour. Well, I want to know how many hours it's going to take for the sun to get to us from here. So I'm going to divide this answer by 15 degrees, and it'll tell me the hours, minutes, and seconds it's going to take to get here. All right, I divide by 15 and I hit the degree, and then I hit enter. Hit enter one more time, and it says the answer, divide this by 15, and the answer is 7.659 blah blah blah. That means 7 hours and something. So I can go back up here and convert this to hours, minutes, and seconds. Now I did not show this to you in the previous video, so this is something entirely new. You may want to rewind this and take a good look at it, because you're going to be doing this all the time in celestial navigation. I'm going to convert this back. How do I convert it back? I hit the degree function. I hit my left arrow. I want to change this back to degrees, minutes, seconds, but in this case it'll be hours, minutes, seconds. I hit enter twice. It is going to take it 7 hours, 39 minutes, and 34.47 seconds to get here. So that's 7 hours, 39 minutes, 34.4 seconds to get here. Okay, now I just taught you something new. We went from degrees, minutes, and seconds to hours, minutes, and seconds. And that's really hard for people to grasp in their mind how you can work back and forth. I have a lot of trouble with people confusing that. So go back, please, and watch this again and again until you understand it. In other words, let's review what we've got here since I wrote it all down. The sun is at 30 degrees, 21 minutes, 33 seconds west longitude. We are at 145 degrees, 15 minutes, 10 degrees west longitude. That means we are by subtracting one from the other, we know that there is a distance in degrees, minutes, and seconds of 114 degrees, 53 minutes, 37 seconds between us, between the sun and us. We want to know, when is the sun going to be here? All right? We know that the sun, once again, on this paper, the sun travels 15 degrees every hour. 15 degrees an hour. So we simply divide this distance in degrees, minutes, and seconds by 15 on the calculator, 15 degrees. If you tried to do this in your head, it'd take you the rest of the week. Believe me, I've tried. It's much better to do it on a calculator. That's why I say keep a calculator in your nav station on board your sailboat to use. All right, we take this, we divide it by 15, It gave us 7.659. We convert that with our function here, with our degree, minute, and second function. We take it from decimals back to hours, minutes, seconds, and it told us 7 hours, 39 minutes, and 34 seconds for the sun to get here. Okay, now let's reverse this process. No, let me start over again and show it to you once again. Now watch me closely. Okay. Here's the Earth. Here is the prime meridian. That is 0 degrees longitude. The sun is at 3021, so we come over here. The sun is right here at 30, 21, 33. Here's 90. Here's 180. So we are right up here somewhere. Here's where we are at 145, 15, 10. You notice I didn't put the symbols. I'm teaching you something else. When I do this out on my sailboat, I'm taking a shot. I never put all these symbols. I just use hyphens between them. All right. Now, we want to know this distance right here. From the sun's position to us, we want to know that. Well, we're just going to subtract this from this, and that'll give us that. Then we know the sun travels at 15 degrees an hour. We want to know how many hours to get up here to us. All right, so that's what we're going to do. That's the theory. Let's take our position, 145, 145, put it in. 15, push the degree function, and we got to move it over to to minutes. Then we put in 10. We move that over to seconds. All right. Now we're going to minus. See, it's in there. It says 45 degrees, 15 minutes, 10 seconds. Now we're going to subtract the sun's position. The sun's position is 30. Hit our degree function. 21. Hit our degree function and move it over to minutes. 33 seconds. Put in 33. We got to move it over to the seconds. All right, we hit enter. Now we're ready for an answer. We hit enter again. We get 1148936, just what we got up here. We hit the degree function. We take our little arrow, go to the left to the degree, minute, second function. We hit enter once and twice, and then it tells us 114 degrees, 53 minutes, 37 seconds. Now that's the distance in degrees between the sun and us. This is 114, 53, 37. Now how long is it going to take the sun to travel up to us? Let's take it. We know it goes at 15 degrees an hour. So we're going to divide this answer by 15 degrees. Ready? Let's do it. It says 7.659. Blah, 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 blah. Well, that's in decimals. So let's convert it. Push the degree button. Use our left arrow. It says degrees, minutes, seconds, but it works just as well for hours, minutes, seconds. We're going to hit enter. One more time. 7 hours, 39 minutes, 34.47 seconds. All right. That is how you do that. That is how you work that up. Go over this again and again until you feel very comfortable with it. Make up some imaginary problems of your own. to work. Make up some imaginary problems. This works great as long as you don't... Now, let me warn you. When you're working your problems, if you're going to make up some, don't go past the international date line. You're not ready for that. This is 180, so don't put yourself past 180, because then you throw a monkey wrench in the operation. You've got to subtract. Then you're in east longitude. Okay? And that is going to cause you a little trouble if you don't think it out real well. All right? We may do one of those later. But for right now, stay on the west side of 180 and work out some problems on this. In class, in the Celestial Navigation class, we'll get into doing this other. But I want you to, first of all, be comfortable working on this side. Okay, let's do another little problem here. Now, let's say this is the equator. And here I am. And I am at 99 degrees, 33 minutes, and 59 seconds. That's my latitude longitude. That's where my sailboat is. Now you, in your sailboat, are over here at 11 degrees, 59 minutes, and 21 seconds. Now we're on the equator. How many degrees separate us? How many degrees are there between us on the equator? How many degrees, minutes, and seconds are there between us? Stop this video and work that problem and write down the answer. And then I will work it right here. All right? 5, 4, 3, 2, 1. Stop the video. Okay, now start the video again. Okay, I'm going to work this problem and let's see if you got the same answer hopefully I will get. All right? We're at 99. I'm at 99, 33. I've got to move this over. 59. And I am going to subtract your position of 11, 59, 21. We hit enter. All right, it says 87, 57, blah, 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 blah. How do we change that from 87, 57? Now, I showed you on other calculators. On other calculators, you can use this little button up in the left corner. Let's look at this calculator here. Remember this calculator from an earlier one? You use the inverse button and push the degree function. And that switches it back. But on this calculator, it's different. We hit the degree function. We take it back one to where it says DMS, then we hit enter. 87, 34, 38. Okay, that's 87 degrees, 34 minutes, 38 seconds. That is what separates you and I on the equator. Now we can do the same thing on a latitude line. I am at 33 north, or north 33, 21, 59. You are at north 01, 27, 27. How far apart are we? We're on the same meridian, so it's strictly a matter of north-south distance. I'm at north 33, you're at north 01. What's the answer? Stop the video, work the problem. 5, 4, 3, 2, 1. Okay. All right. Let me do this problem, and hopefully I'll get the same answer you got. All right. 33, 21, 59, minus, you're at 1, 27, 27. All right, we got it in there. We hit enter. It tells us there's 31.90 blah, 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 blah degrees between us. Let's convert it to degrees, minutes, seconds. There are 31 degrees, 54 minutes, 32 seconds between us. Okay, well, this is enough on these problems. Go back and watch this video, make some of your own problems, work them out, get to know your handheld calculator very well so that at the Celestial Navigation class, you'll be ready to go and be able to use it to make all these calculations. Believe me, it's a lot easier than trying to do this stuff in your head, as long as you understand your calculator. And of course, yours may function differently than this one. So I have to count on you to study your own and become familiar with it. Okay, well, once again, if you have any questions, you can email me at www.globizon.com. It's actually sales@globizon.com, and I'll be happy to answer any questions. If you want me to call you on the telephone, include your phone number, and I will definitely call you. Okay? Thank you very much.